What's good? What's good? All right, so hopping back into Python. Right now I'm at Introduction to Higher Order Functions. So let's get into it. Got to deal with this Codecademy lag, but it's all good. So, Introduction to Higher Order Functions. In this article, you will learn about higher order functions, a unique type of function. Functions as first-class objects. So far, we have explored the core benefits of using functions in our programs. We have seen firsthand how using functions allows for better coding modularity, readability, and extensibility. Many of these benefits stem from the ability of functions to be extremely flexible. In Python, functions are treated just like any other object, which in turn gives them the power to be used in a variety of ways. In order to understand the power of functions, let's explore what it means for functions to be objects. In Python, all functions, including the ones we've written, are classified as first-class objects, sometimes also called first-class citizens or first-class functions. This means they have four important characteristics. 1. First-class objects can be stored as variables. 2. First-class objects can be passed as arguments to a function. 3. First-class objects can be returned by a function. 4. First-class objects can be stored in data structures, e.g. lists, dictionaries, etc. We have taken this functionality for granted before if we ever assigned we may have taken this functionality for granted before if we ever assigned a function to a variable or stored a function in a list, like in these examples. So here we assign a function to a variable, uppercase equals string.upper, and then call it big pi equals uppercase pumpkin pie. I don't think, at least not in this course, we haven't assigned a function to a variable like this, or maybe something like this. Here we store two functions in a list. String manipulation functions equals a list of string.upper and string.lower. But the fact that functions are first-class objects in Python, and therefore have all the flexibility of objects, enables us to write even more powerful types of functions called higher-order functions. Higher-order functions operate on other functions via arguments or via return values. This means higher-order functions do one or both of the following. Accept a function as an argument, have a return value that is a function. Let's dive into each of these properties to see this special type of function in action. Functions as arguments. Let's start with higher-order functions that take another function as an argument. We'll go through a series of examples using a higher-order function, total bill, that takes another function as one of its arguments. This function aims to use other functions taken in as arguments to calculate the total bill at, say, a restaurant or cafe. By examining each example in turn, we will learn how to use higher-order functions and why exactly they are so powerful. Later on, we will come back to higher-order functions that have a function as a return value. Here we go. Take a look at the example higher-order function called total bill. Def total bill, func value, total equals func value, return total. The total bill function takes two arguments, func and value. When called, total bill applies func to value and returns the result. In order to see it in action, let's define a function called add tax and then pass it to our higher order total bill function along with a numeric value. So we have def add tax, which takes in total. Tax equals total times 0.06. New total equals total plus tax. Return new total. Total bill is add tax 100 with output 106. So if we pass this add tax and we do total equals us passing this value of 100 to add tax. So then it does 100. Yeah, it makes sense. Here total bill is classified as a higher order function because it takes in an argument that is a function. Add tax in the above example. Right off the bat, this setup may not be very useful compared to simply calling add tax 100 directly, but what if we wanted to add a tip instead of tax? Let's see how we can reuse our higher order function to add a 20% gratuity instead of a 6% sales tax. So here we see def add tip, which takes in total. Tip equals total times 0.2. New total equals total plus tip. Return new total. Total bill, add tip 100 with output 120. So here we're defining add tip, which takes in a total. And later we use total bill function and send the add tip with 100. And this is doing tip equals total times 0.2. And new total equals total plus tip, return new total. We can see that we can reuse total bill for both of these functions, but this still isn't any more useful than calling the function add tax or add tip directly on a value. The true power comes when we want to keep a consistent manipulation no matter what function is passed in. We can see this if we modify our total bill function so it adds formatting to the total amount owed in a consistent and friendly way, regardless of which function is passed in. So def total bill, func value, total equals func value, return. The total amount owed is $ plus this regex. I think that's a regex, maybe it's not. But dot format total plus period. Thank you. I know that this is setting it to format with 2 decimal places. That's what I know. Print total bill, add tax 100. Print total bill, add tip 100. Would output the total amount owed is 106. Thank you. The total amount owed is 120. Thank you. So now, no matter the function we pass as the argument and the behavior we want the function to accomplish, we can always consistently format the total and add a friendly message to the returned result. While we are only adding on a small manipulation at this point, we can really do any consistent manipulation that increases our code reuse and makes our programs more modular. This isn't the only situation where higher order functions shine. They are also fantastic for situations involving iteration. Functions as arguments, iteration. Let's return to our total bill example. Now say we have a list of bills instead of just one, and we want to add tax or tip to each bill, depending on the type of sale it is. One way to accomplish this could be to write out separate loops, one for sales that need to have tax added, and one for sales that should have a tip added. To get a sense of what this would look like, let's write out the loop for adding tax first. So bills equals 115, 120, 42. New bills is an empty list. For I in range, the length of bills. Total equals add tax bills I. So we're calling our add tax function on bills I. So it'll start with bills 0 and run the add tax function on 115. New bills dot append. The total amount owed is $. The formatting dot format. So taking this total and formatting it with 2 decimal places. Plus, thank you, print new bills would output this list. Now we could write out another loop for when we need to add a tip instead of tax, but we can probably guess how many repetitions would be involved. A much more powerful solution would be to use a higher order function to apply add tax or add tip to each balance in our list. Let's first define a higher order function, total bills, that takes a function and a list as arguments, applies the function to each element in the list, standardizes the format of the result, and adds a friendly message, appends the output to a new list, and finally returns the updated new list. So def total bills func list. This list will store all the new bill values. New bills equals an empty list. This loop will iterate through our bills for I in range length of list. Here we apply the function to each element of the list. Total equals func list I. New bills dot append. Total amount owed is $, plus this formatting total plus thank you return new bills. Now let's use the add tax function that we wrote before with our new total bills higher order function. Bills is this list. Bills with tax equals total bills, add tax bills, print bills with tax. Would output total amount owed is $121.90. Thank you. So and so on. And if we needed to add a tip instead of tax, we could simply swap out the function argument. So bills with tip equals total bills, add tip bills, print bills with tip, and so on. As these examples show, being able to pass functions in as arguments can be pretty handy, especially when we want to apply a function multiple times. In fact, it's so handy that there's a built-in higher order function in Python that does just that, the map function. We will learn more about the map function in upcoming articles. Now that we have explored functions as arguments, let's turn toward higher order functions that have functions as return values. Functions as return values. So far, we have focused on higher order functions that take another function as an argument. Remember though, that a function that returns another function is also a higher order function. Let's see what this looks like in practice by considering a higher order function, make box volume function, that will help us calculate the volumes of boxes when they have the same height. Def make box volume function height defines and returns a function that takes 2 numeric arguments, length and width, and returns the volume given the input height. So def volume length width, return length times width times height, return volume. Box volume height 15 equals make box volume function 15, print box volume height 15, 3, 2 would output 90. And if we had slightly shorter boxes, box volume height 10 equals make box volume function 10. Hold on, this isn't sinking in. Functions as return values. So far, we have focused on higher order functions that take another function as an argument. Remember though, that a function that returns another function is also a higher order function. Let's see what this looks like in practice by considering a higher order function, make box volume function, that will help us calculate the volumes of boxes when they have the same height. So here we see def make box volume function, which takes in a height. It defines and returns a function that takes two numeric arguments, length and width, and returns the volume given by the input height. So within this make box volume function, we're defining volume, which takes in length and width. It returns length times width times height, and then returns the volume. So then outside of these functions, we can run box volume height 15 equals make box volume function 15. And then when we print box volume height 15 and pass it 3 and 2, those 3 and 2 get passed to the inner function volume, and it prints out 90. Pretty cool. And if we had slightly shorter boxes, we do box volume height 10 equals make box volume function, and we pass it 10 for the height. And then when we print box volume height 10 and pass it 3 and 2, those get passed to the inner volume function, and it outputs 60. In the example, we wrote a higher order function, make box volume function, that takes a height as an argument and returns a new function that calculates the volume of any box with that height when it is past the length and width of the box. As we can see, higher order functions with functions as return values are just as reusable as higher order functions with functions as arguments, and therefore also reduce repetition and the chances for mistakes to creep into code. Our appreciation for this will grow as we keep writing more code and our code becomes increasingly complex. Wrap up. Great job. We have explored many new concepts surrounding higher order functions. To summarize, we learned 1. Higher order functions are possible because functions are first-class objects in Python, meaning that a function can be stored as a variable, passed as an argument to a function, returned by a function, and stored in data structures, lists, dictionaries, etc. 2. Higher order functions are functions that operate on other functions by taking another function as an argument, returning another function, or both. 3. Higher order functions can reduce repetition in code, making code easier to read and less prone to mistakes. As you keep practicing and writing more code, higher order functions will make your code faster, more elegant, and easier for collaborators to understand and reuse. Next up, we'll learn about several built-in higher order functions in Python. Let's see what's up next. Built-in higher order functions. In this article, you'll learn about 3 useful higher order functions that are built into Python. What you'll be learning. We've already learned about what defines higher order functions, how to use them, and why they're useful. Now, we will get acquainted with Python's built-in higher order functions. We will take a look at 3 distinct higher order functions. 1. Map. 2. Filter. 3. Reduce. Together, these 3 functions are some of the most used and powerful higher order functions in Python and will help us elevate our Python programs. Map. The map higher order function has the following base structure. Returned map object equals map function, comma, iterable. When called, map applies the passed function to each and every element in the iterable and returns a map object. The returned map object holds the results from applying the mapping function to each element in the passed iterable. We will usually convert the map into a list to enable viewing and further use. So let's check this out. So map function iterable. If our iterable is 369, we're mapping what's the function? Returns a map object with the output of function 3, function 6, function 9. Let me read this again. When called, map applies the passed function to each and every element in the iterable and returns a map object. The returned map object holds the results from applying the mapping function to each element in the passed iterable. We will usually convert the map into a list to enable viewing and further use. Let's see what this looks like in practice if we wanted to double every value in a list of numbers. Def double x, return x times 2. And we have int list equals 3, 6, and 9. Doubled equals map double int list. So we're mapping this double function onto every element of int list. And then if we print doubled, it would output map at this memory location. In our example, we defined a function called double that takes in a value and returns the value doubled. This function can be used anywhere in our program, not only with map. We also defined an iterable int list that we wanted to apply the function to. We then passed the function reference double as the function argument and int list as the iterable to map. The map function proceeded to apply double onto each element in int list. When we printed the result, we could see that the output of the map function was a specific type of object called a map object. If we want to see the actual results of mapping double to the elements of int list, we need to convert the map object to a list using the built-in list function. So if we do print list doubled, this would output 6, 12, 18. Using a lambda function with map produced the same output as when the custom double function was passed to map, but it only required one line. Oh, I didn't even look at this. Higher order functions like map work especially well with lambda functions. Because lambda functions are anonymous, we don't need to define a new named function for map if that function won't be used again elsewhere. In this case, if we don't plan on reusing double somewhere else in our program, we can rewrite the double function from the previous example with a lambda function like so. Doubled equals map lambda input times 2 to int list print list double. Oh, it's pretty useful, yeah. So we can call this mapped built-in higher order function, pass it in a lambda function as the function, and we can do lambda lambda the input, and what we do, we multiply the input by 2, and the input ends up being this int list as per the map function. Using a lambda function with map produced the same output as when the custom double function was passed to map, but it only required one line of code instead of 3. Now, let's practice using map to apply a lambda function to each element in a list. Say we stored our course grades in a list, but some of the grades were on a 4-point scale where students score between 0.0 and 4.0, and others were on a 100-point scale where students scored between a 0 and a 100. To get all the grades on the same scale, try using a lambda function inside of the map function. Multiply the grades on the 4-point scale by 25 to convert the grades to a 100-point scale. So we have this grade list of a mix of grades. The first 3 are on the 4.0 scale, and the last 2 are on the 100 scale. Your code below. Assign the result of your map function. So make 100 equals map lambda input so I guess I could do lambda input times 25 if input less than 4, else input, and then we could do grade list. Assign the result of your map function to the variable grades 100 scale. Grades 100 scale equals make 100. Convert grades 100 scale to a list and save it as updated grade list. So print updated grade list. What I do? I mess up the lambda, huh? Invalid syntax. is it like this? If input less than 4, let's consult my good old friend, Young Chat. How do I add an if-else statement to a lambda function in Python? In Python, if you include an if-else statement inside a lambda function using the following syntax. So lambda x, value of true. So in my scenario, it would be lambda input times 25 if input is less than 4, else input. And even just to match the style, right? I'm just gonna do lambda x times 25 if x is less than 4, else, right? Lambda x times 25 if x is less than 4, else x. Grade list invalid syntax. The error in your code is due to syntax mistake in the lambda function within the map call. Additionally, there's a typo when converting grades 100 scale to a list. Here's a breakdown. In the lambda function, you have an extra colon after lambda. Ah, I see. And then what I do, I see. Nice. You got it. What's their hint? The format for including an if-else statement within a lambda function is lambda arguments, colon, return value if condition is true, if condition, else, return value if condition is false. Filter. Similar to map, the filter function takes a function and an iterable as arguments. Just as the name suggests, the goal of the filter function is to filter values out of an iterable. The filter function accomplishes this goal by applying a past filtering function to each element in the past iterable. Again, similar to map, the filter function takes a function and an iterable as arguments. Just as the name suggests, the goal of the filter function is to filter values out of an iterable. The filter function accomplishes this goal by applying a past filtering function to each element in the past iterable. The filtering function should be a function that returns a Boolean value, true or false. The returned filter object will hold only those elements of the past iterable for which the filtering function returned true. So if we do filter function iterable equals 369, function 3 returns true, function 6 returns true, function 9 returns false, returns a filter object with only 3 and 6. Let's see what this looks like in practice with a function that filters a collection of names and returns only the names that start with the letter M or M. Names equals Margarita, Linda, Masako, Maki, Angela. M names equals filter, lambda name 0 is equal to M, or name 0 is equal to lowercase m names, print list M names. So this filter, so this function lambda, the input is a name, and it returns name equal to 0. So it returns true if the name is equal to 0, or true if the name is equal to M. Okay, makes sense. I'm a little bit confused. Wouldn't this work also with the with the map function, because you're also mapping these onto this. Filter takes two parameters, the lambda filtering function and the list names. The filter function then iterates through names and applies the lambda function to each item in the list. For each item in the list, if the condition in the lambda function evaluates to true, the item is added to a filter object. The filter object is returned, and when converted to a list and printed, we saw that it contained Margarita, Masako, Maki, only M names. Let's get some more practice using filter with a lambda function. We were given a list of lists where each sublist holds the title of a famous book that has a year as its title and the last name of the author that wrote the book. Unfortunately, when this list was made, each of the books was accidentally entered twice, once with the title as a numeric value and once with the title as a string. Use the filter function to deduplicate the list and keep only the sublists that have the book title stored as a string. I didn't read that. We were given a list of lists where each sublist holds the title of a famous book that has a year as its title and the last name of the author that wrote the book. So here we see Burgess 1985, Orwell 1984, Murakami 1Q85, Orwell 1984, Burgess 1985, Murakami. And again, each sublist holds the title of a famous book that has a year as its title and the last name of the author that wrote the book. Unfortunately, when this list was made, each of the books was accidentally entered twice, once with the title as a numeric value and once with the title as a string. Use the filter function to deduplicate the list and keep only the sublists that have the book title stored as a string. Your code below. Assign the result of your filter function to the variable string titles. So string titles equals filter. Which one do we want again? Deduplicate the list and keep only the sublists that have the book title stored as a string. So filter lambda x if x1 type x1 is equal to string. I don't remember if that's exactly. No, let's not go to ChatGPT. Let's go to Python type. No, I refuse. Don't make me do this. All right, fine, just take it. Oh, it's still output. Class int, okay. Class string, okay. In quotes. Else. String titles equals filter, lambda x, x. Sorry. So filter lambda x type x1 equals. Wait, we're taking the books list, right? This is wrong. Or you can select an element in a list by its location, list 0, and you can check whether value is a string, integer, or float with the type function. So that's what I thought. But if I run x1, isn't it, and I give it the book, that's not going to work, is it? String titles equals filter, lambda, input is x. Oh yeah, I forgot that it goes through all of them. It goes through each one. So it's not looking at books 1, it's looking at the first sublist of books 1. Right. That makes sense. So again, string titles equals filter lambda x, type x1 is equal to class string books. Convert your filter object to a list stored in the variable string titles list. So string titles list equals list string titles, and then print the list string titles list. I suck at lambdas. The issue with your code lies in the use of class string within the filter function. Python, the correct way to check if a variable is a string is by using string, not class string. Here's how you can check your code. So string titles equals filter lambda is instance x1 string. How would I do this? To achieve the same functionality using type instead of instance, you can modify the lambda function within the filter call. Here's how you would do it. So filter lambda x type x1 is equal to string. Oh, I see. I overcomplicated things. Nice. You got it. Reduce. Lastly, we have the reduce function, which has two distinct differences from the built-in higher order functions that we have returned so far. In contrast to the map and filter functions that are always available, the reduce function must be imported from the func tools module to use it. Rather than returning a reduce object, as might be expected after learning about map and filter, reduce returns a single value. To get to this single value, reduce cumulatively applies a passed function to each sequential pair of elements in the iterable. So see, reduce function iterable. The iterable is 3, 6, 9, 12. The function returns x, returns y, returns z. And again, we have the reduce function, returns a single value of z. We have the reduce function, which has two distinct differences from the built-in higher order functions that we've learned so far. In contrast to the map and filter functions that are always available, the reduce function must be imported from the func tools module to use it, rather than returning a reduce object, as might be expected after learning about map and filter. Reduce returns a single value. To get to this single value, reduce cumulatively applies a passed function to each sequential pair of elements in an iterable. Again, in contrast to the map and filter functions that are always available. Okay, I got that. 2. Rather than returning a reduce object, as might be expected after learning about map and filter, reduce returns a single value. To get to this single value, reduce cumulatively applies a passed function to each sequential pair of elements in an iterable. Let's see what this looks like in practice by using reduce to multiply together all the values in a list. So from functools import reduce, int list equals 3, 6, 9, 12, reduced int list equals reduce lambda xy, x times y, int list. Print reduced int list. This would output 1944. In this example, the reduce function takes two arguments, a lambda function and a list of integers. The lambda function takes two numbers, x and y, and multiplies them together. The reduce function applies the lambda function to the first two elements in the list, 3 and 6, to get a product of 18. Next, 18 was multiplied by the following element in the list, 9, to get 162. Continuing on, 162 is multiplied by the next element, 12, to get 1944. This last final value, 1944, is what was returned by reduce. This process was essentially the same as multiplying 3 times 6 times 9 times 12. Let's get some more practice using the reduce function with a lambda function, but with a list of strings this time. Given a list of letters, use the reduce higher order function with a lambda function to combine the letters into a single word. So letters equals reduce, your code below. Remember to import the reduce function. So import reduce from functools. Is that the right way to do it, or is it the other way around? From functools import reduce, yeah. From functools import reduce. And store the result of your reduce function in the variable word. Word equals reduce lambda x. I should say lambda xy. And then outputs x plus y letters. Print the word. Run it. Reduce. Awesome. Wrap up. Great job. We learned all about 3 really important built-in higher order functions in Python. To summarize, we learned 1. The map function applies a passed function to each element in an iterable and returns a map object. 2. The filter function applies a filtering function, a function that returns a boolean, to each element in an iterable. Filter returns a filter object with only the elements for which the filtering function returns true. 3. Reduce must be imported from the functools module. It reduces an iterable to a single value by cumulatively applying a passed function to the first pair of elements in the iterable and then each sequential element with the return value. These 3 functions streamline code on their own, but they are even easier to read when they are used in conjunction with lambda functions. As we keep practicing and writing more code, these higher order functions will make our code faster, more flexible, and easier to understand. What's next? Decorators. Gonna watch this video, but first, let me bring you guys in. But first, and let me bring this down. Still want it a little bit. That's cool. Get out of here. Hope that's not too loud. That looks pretty loud. All right. Get out of here. I don't know. I don't want the video to come in crazy loud. I guess I'll bring it down to here. Let's get back to it.
Hey, my name is Mike. I'm a developer from Philadelphia, and in this video, I want to talk to you about decorators in Python. Now, decorators are basically special functions which we can use to add functionality to existing functions. And we can do this in a very convenient way and in a way that makes our programs a lot easier to read and write. So I'm going to walk you through exactly what decorators are. And not only that, I'm going to talk to you a lot more about what functions are in Python. So you've probably been using functions up to this point, but there's a lot of things about functions that you might not realize. And so we're going to go through this entire little curriculum that I have here, 6 different steps. I'm going to talk to you about 6 different ways that we can use functions and eventually use decorators. So let's start up here. We're going to start with functions as objects. Now, one thing that you might not realize about Python is that all functions are actually objects. And that basically means that a function is very similar to something like a string or a number or a list. Basically, a function can be used in the same way that these other data types can also be used. So to prove that, I'm going to go ahead and create a function, and I'll show you how this works. So let's create a function. We're going to call it add5. Basically, what it's going to do is it's going to take a number, and then it'll add 5 to it. So we'll print out the result of num plus 5. So it's a pretty simple function. all it does is just add 5 to a number and print it out. And why don't we go ahead and execute this? So down here we can just type add 5, and so in here why don't we pass in a 2, for example. So we're going to pass in 2 into our add 5 function, and then over here I have my terminal, and I'm just going to type in Python 3, and I name this file decorators.py. So I'm going to hit enter, and you see over here that we get 7. So 7 is the answer to the function, did exactly what we wanted it to do. Now let me show you something interesting. You'll notice that whenever we use functions in Python, we always use these open and closed parentheses. And you might be wondering what exactly these do. And essentially, when you put an open and closed parentheses after a function, it indicates that we want to call the function. So we want to execute all of the code inside, potentially with some given arguments. But what happens if we take away these parentheses? What happens now? If I run my program, you'll notice that nothing happens. The program doesn't execute the code that's inside of this function. We don't print out anything. We also get an error, and that's because it's perfectly okay to have functions like this. In fact, if we print out this function without making an open and closed parentheses after it, you'll see over here that we actually get a result. So if I run my program, you'll see here that it says function and it has its name, add 5, and then this over here is memory address. Basically, this function is an object. So it's an entity in our program, much like a number or a string that we can use. And the way that functions get invoked is with the open and closed parentheses. So if I wanted to call this function, I could make the open and closed parentheses, and then it would go ahead and print out the number plus 5. And so there's a difference here between a function with an open and closed parentheses after it, which is essentially us telling Python that we want to invoke the function, execute all the code inside, and just having the function like this without the open and closed parentheses. And so this right here is an object just like a number, just like a string, just like a list, just like any of those other objects that we're used to working with in Python. And so the cool thing about this is now that we know that these are just objects, we can use them similar to the way that we use numbers and strings and lists. We can pass them around, we can store them in variables, we can use them as parameters and arguments into functions, we can do all of those different things. So now we have an understanding of how functions are actually objects. Why don't we go ahead and talk about functions within functions? So I'm going to actually copy this, so we'll bring this down here. So now we're going to talk about functions within functions. So we have our same function here, add 5 function. Now, let's see if we can make this a little bit more complicated. So in here, inside of my add 5 function, I'm actually going to define another function. So in here I'm going to say add 2, and in here we'll also take a number as a parameter, and in here I'm just going to return num plus 2. Now, you'll notice that this function is declared, it's created inside of the bounds of the add 5 function. So this function is actually created inside of here. Now check this out. Down here, still inside the add 5 function, I could actually use this add 2 function. So over here I can create a variable, and why don't we call this num plus 2, and that's going to be equal to the result of calling add 2 on our number. Now remember, num right here refers to this number up here, the number that we got as input to the add 5 function. So basically what I'm doing is I'm calling the add 2 function on this number, and I'm storing that inside of a variable. So now num plus 2 stores the value of the number that got passed in plus 2. But I was able to get that value by calling a function that I defined inside of the add 5 function. So now over here I can print out num plus 2 plus 3, and this would be the same as adding 5 to that number. So then if I came down here, I could do add 5, and in here if I pass in a 10, we should get a 15 back. So it should print out 15. So if I run this program, you'll see that we print out 15. So how does this actually work? Well, we defined a function inside of our add 5 function, and then we were able to use it. But check this out, and this is where it gets a little bit interesting. If I try to execute that add 2 function, if I try to call that, so if I try to call add 2 with argument 7, watch this, we're going to get an error. We're getting a name error. It says add 2 is not defined. Now notice we didn't get a name error when I called add 2 here inside of my add 5 function. And that's because the add 2 function is declared in the scope of the add 5 function. So because it's here in this indentation block inside of the add 5 function, it's actually inside of this scope, which means I can only access it within the add 5 function. So if I try to access it out here, I can't do that. And that's something interesting that we can do with functions. We can define them inside other functions, and then we can use those functions in there to do different things, just like I did over here. So now we learned about how functions are just objects. We also learned about functions within functions. And so now I want to talk to you guys about returning functions from functions. This is another special thing that we can do in Python. We can do it with functions, and it's actually really interesting. So let's create another function, and I'm actually going to call this getMath function. So this is going to be a function that's going to take in an operation, and this is going to be a addition sign or a subtraction sign. And basically what this function is going to do is it's going to return a function that adds or subtracts a number. So this is maybe something that you've never done in Python before. So inside this getMath function, we're going to define 2 functions. So I'm going to define add function in here, and it'll take num1 and num2, and then over here we'll just return num1 plus num2, right? We're adding them together. And I'm also going to define a subtraction function. Again, it's going to take num1 and num2, and then down here it'll return num1 minus num2. Now notice what I did here. I didn't actually add or subtract any numbers. All I did was create 2 functions that are capable of doing that. They're capable of performing an addition or a subtraction operation. And we saw how we can create functions within functions. Now check this out. Down here I can create an if statement. So I'm going to say if operation is equal to addition, if it's equal to a plus sign, then I'm going to return the add function. And then I can say else if operation is equal to a subtraction sign, then down here I'm going to return the subtraction function. So I'm not returning a number, I'm not returning a string or a list, I'm returning a function. And remember, functions are just objects, right? We talked about that. And so we can pass them around, we can return them, we can input them as parameters in functions, just like we can with numbers and strings and lists. And so here it's perfectly valid for us to return a function from over here. So we have our getMath function, and now over here I'm actually going to call this. So I'm going to create a variable called add function, and I'm going to set it equal to the result of calling getMath function, and in here I'm going to put a plus sign. So let's think about what's going to happen here. What's going to get stored inside of add function? This is our variable. Well, we're going to call getMath function, and we're going to call it with a plus sign. So the getMath function creates these 2 functions. And then down here, if the operation is a plus sign, which in our case it is, it's going to return this add function. So over here, add function, if we print this out, it should be a function, because we returned a function from our function. You know something with function a lot. That happens when we talk about these nested functions and all that stuff. So it's our program, and whoops, little syntax mistake here on the else if. And so when we run our program, you'll see that it prints out function, and it's the getMath function dot add function. So this is our add function. So now if I called my add function, this is going to take like maybe a 4 and a 6. Now we should get back 10. So you'll see here I'm printing 10. So why is this working? Well, this add function, remember, it got returned from the getMath function. This add function is actually this function up here, and it takes in num1 and num2, and I returned it. So over here, we can do the same thing. I could say subtraction function, and that could be equal to getMath function, and then in here we put subtraction sign. So now I could do our subtraction function with the same inputs, and we should get a -2. So now it's subtracting these 2 numbers. So this is a really important concept when we're talking about functions, and as we move towards talking about decorators, which is returning functions from functions and also defining and declaring functions within functions. Okay, so that's going to do it for our returning functions from functions section. So now we have an idea of how you can return functions from different functions, and you can store them in variables, and then you can execute them if you want. Now let's talk about decorating functions. So we're moving more towards this concept of a decorator. And actually, we're going to be introducing the concept of decoration in this section. So I'm going to create a function, and I'm going to call it print my name. And this function is just going to print my name. So my name is Mike, so that's what it's going to do. It's going to print that out. So down here, if I call print my name, then we should print out Mike. So let's do that over here. You see we print out Mike. It's exactly what we expected, right? This is pretty simple. Now, what I can actually do is I can make this function a little bit more powerful by using a decorator. And a decorator is basically, it's another function which will take this function and it'll kind of add some functionality on top of it. So it'll do some stuff in addition to doing this function right here, executing that function. So let me just show you real quick. We're going to create a title decorator. And basically what this is going to do is it's going to take this print my name function, and in addition to printing my name, it'll also print out a title for me. So, whatever title would be, like, title might be like doctor or senator or professor or whatever, a title that someone would have before their name. That's what this title decorator function is going to do. So this is actually our first decorator function. And this is going to take in a print name function. And you'll see how this all comes together in a second, but for now just stick with me. Now in here, I'm going to create something called a wrapper. Remember, we can create functions within other functions. We saw how we can do this. And this wrapper function is essentially going to be a new function which wraps this print name function with some other functionality, and then we'll return that. So over here, I'm going to print out a title. So maybe I can print out a title like professor. So this is going to be my title. And then down here, what I'm going to do is I'm actually going to execute the print name function that got passed in. So I'm going to execute that, and then over here, we're going to return wrapper. And so that's going to be our entire decorator function. Now, this doesn't make perfect sense right now. Don't worry. We're going to see in a second exactly what it's doing. So down here, I'm going to create a variable called decorated function. And I'm going to set this equal to title decorator. And then in here, I'm going to pass in print my name. So now notice what's happening here. I'm calling the title decorator function, right? I'm passing in this function. Remember, functions are objects, so we can pass them into functions just like we would with strings or numbers or lists. So I'm passing a function here into this title decorator function. It's the print name function. In our case, it's print my name. And then I'm defining a function from within here. And in this function, when this function, this wrapper function eventually gets executed, it'll print out professor, and then it'll call the print name function, which will print the name. So essentially, we're printing this title, and then we're going to print whatever the name is. And that function gets returned. So we're storing that wrapper function here in decorated function. Now over here, if I execute decorated function, see if you can figure out what's going to happen. I'll give you a second here. So why don't we go ahead and test this out? Let's just run the program and we'll see what happens. You'll see here what gets printed out is Professor Mike. So essentially what we did is we took this existing print my name function, we passed it here into a decorator. The decorator then took that function and it wrapped it up with some additional functionality which printed a title before the name, and then it returned that new function. So a decorator function, all it does is return a new function which executes that existing function that got passed in along with some additional functionality. So we would call this decorating a function because we're decorating the print name function with some additional prints or whatever. I mean, it could be any possible thing that you could put in code to go here in a decorator. So that's kind of how a decorator works. Now I encourage you to play around with this. One thing that's really important to understand is this line right here and how this all comes together. So we call title decorator, we pass in a print name function, and then that passes us back a wrapper function which we can then execute. So just to illustrate this a little bit more, I'll actually create another one of these name functions. So I'll say print Joe's name. So this is going to be a function which prints out Joe's name. So in here we'll print out Joe. Now check this out. This decorator function takes a print name function. I have print my name and I also have print Joe's name. So in here I could pass in print Joe's name. And if I execute my program, now instead of saying Professor Mike, it's going to say Professor Joe. I passed it a different print name function here as an argument. So that's kind of how that works. So now that we've taken a look at that type of situation, so this whole situation where we have a decorator function, and then we also have some other like print name functions, I want to show you guys a way that we can seriously simplify this syntax. So down here in this fifth section, I want to talk to you about Python decorators. So we saw how we can create a decorator function, but there's a way of doing this in Python, which is actually really easy. So the complicated syntax is down here, right? This is kind of annoying where we have to wrap this function over here, we have to pass it into the decorator. It's a very like tedious and manual process, right? To doing all of this. I can actually get rid of all of this, and up here, I can just make an @ sign, and then I can type in the name of a decorator. So I can type in title decorator. Now check this out. If I just go print my name, if I execute print my name, it's actually going to decorate it automatically. So you'll see here we're printing out Professor Mike. So it'll do all of this code for us, right? All of this is going to be done in the background. Like Python will take care of that, and we can just call the function normally. So you put this decorator annotation right above the function. So that's go directly above here, and then we're able to use that. So I can do the same thing for print Joe's name. So right now if I did print Joe's name and I try to execute this, you see it just says Joe. But if I wanted, I can decorate it.
I just want to say, so I've seen decorators before, and I've always been kind of confused about how they work. You know, when you see code that you don't understand, it kind of just looks like magic. But now I understand what it's doing is it's taking the underlying function below the decorator and passing it to a predefined function with the name of the decorator. Pretty simple.
With the title decorator, and now when I print this out, you'll see we get that title. So that's how decorators work. And the main concept that you really need to understand here is this idea of a wrapper function that gets both defined and returned from the decorator function. This wrapper function is very important because it's this wrapper function which allows us to package up additional functionality with the functionality that's given to us in the form of our print name function.
Oh, and just also to cement the idea, not only are you passing the function to the decorator function, like the function with the name of the decorator, but then when you run the original function, it includes the decorator within the activation. So running the original function, print Joe's name, will now, instead of just printing Joe,
so these decorators,
because we've added the title decorator to print Joe's name, now when we run print Joe's name, it doesn't just run print Joe's name, it passes print Joe's name to title decorator and runs title decorator. It's cool.
Can have a lot of different uses, and as you learn more about Python, you'll discover more and more useful decorators. So a lot of times a decorator like this would be defined in a separate file. It might even be defined in some sort of a library file that you might have to download with pip or something. And the whole point is it kind of gets abstracted away. So all you have to worry about is just doing this decorator annotation, and then it sort of works for you. So I want to talk to you about one more thing. I'm actually going to move this code down one more time. So here in this sixth section, I want to talk about decorators with parameters. So let's say that we wanted to spruce up these functions a little bit. Let's say that I'm actually going to get rid of the print Joe's name function just to kind of clean this up a bit. Let's say that the print name function, I wanted this to be able to take in a name. So the print my name should be able to take in a name, and then down here we'll just print the name. So we can kind of customize what the name is. So in here I could pass in like Shelby, and now if I run this, and notice that I got rid of the decorator, I commented it out. Now when I run this, you'll see that we just print out Shelby. So I can pass in whatever name I want to pass in. But if I put this decorator back in, we're actually going to get an error, and see what happens in a second. So we're going to type error. So wrapper, this function over here, doesn't take any positional arguments, but we gave it the name. So if I want to be able to accept arguments here in my function that's getting decorated, I have to get a little bit fancier with my syntax. So over here, all we have to do here inside the wrapper is we're just going to put args, and then we're going to put kw args. And so we can put that right there, and then we're also going to pass that in here when we execute our print name function. So all you have to do is put these here, and then put these here, and what that'll do is it'll pass in any of the parameters, any of the arguments that were passed into the print name function, into the wrapper function, and then the wrapper function will then pass them into the print name function. So the parameters, the arguments basically just get piped through this function structure, and we'll be able to use that. So now if I was to run my program, and whoops, you have to put 2 stars here, 2 asterisks, and you'll see that it gets separated just fine. And you can put other parameters in here too. So for example, if I put in like an age, I could say, we can print out their age, and then over here, if we pass in an age, you'll see that it does that just fine. So basically you can have as many arguments as you want, and they'll get passed through this structure. So that's going to do it for my explanation on decorators in Python. And really, when it comes down to it, decorators are just fancy ways of working with functions. So as you saw in our decorating a function section, section 4, we don't need this fancy, @ symbol syntax. We don't need that syntax in order to use decorators, but it does make it a lot easier and a lot simpler because we don't have as much complex syntax. So this is kind of what we would call syntactic sugar. It just makes the language a lot easier to use. And Python is super syntactic sugar rich. It's one of the things I personally love about it. And so that's going to do it for decorators. Hopefully you learned something. Hopefully you got some more insights into how Python works and how functions work. Syntax function.
My mind was elsewhere.
If I see that I got the print, say away. So all you have to worry about is just doing this decorator annotation, and then it sort of works for you. So I want to talk to you about one more thing. I'm actually going to move this code down one more time. So here in this sixth section, I want to talk about decorators with parameters. So let's say that we wanted to spruce up these functions a little bit. Let's say that I'm actually going to get rid of the print Joe's name function just to kind of clean this up a bit. Let's say that the print name function, I wanted this to be able to take in a name. So the print my name should be able to take in a name, and then down here we'll just print the name. So we can kind of customize what the name is. So in here I could pass in like Shelby, and now if I run this, and notice that I got rid of the decorator, I commented it out. Now when I run this, you'll see that we just print out Shelby. So I can pass in whatever name I want to pass in. But if I put this decorator back in, we're actually going to get an error, and see what happens in a second. So we're getting a type error. So wrapper, this function over here, doesn't take any positional arguments, but we gave it the name. So if I want to be able to accept arguments here in my function that's getting decorated, I have to get a little bit fancier with my syntax. So over here, all we have to do here inside of the wrapper is we're just going to put args, and then we're going to put KW args. And so we can put that right there, and then we're also going to pass that in here when we execute our print name function. So all we have to do is just put these here, and then put these here, and what that'll do is it'll pass in any of the parameters, any of the arguments that were passed into the print name function, into the wrapper function, and then the wrapper function will then pass them into the print name function. So the parameters, arguments basically just get piped through this function structure, and we'll be able to use that. So now if I was to run my program, and whoops, you have to put 2 stars here, 2 asterisks, and you'll see that it gets separated just fine. And you can put other parameters in here too. So for example, if I put in like an age, I could say, we could print out their age, and then over here, if we pass in an age, you'll see that it does that just fine. So basically you can have as many arguments as you want, and they'll get passed through this structure. So that's going to do it for my explanation on decorators in Python. And really, when it comes down to it, decorators are just fancy ways of working with functions. So as you saw in our decorating a function section, section 4, we don't need this fancy, at symbol syntax. We don't need that syntax in order to use decorators, but it does make it a lot easier and a lot simpler because we don't have as much complex syntax. This is kind of what we would call syntactic sugar. It just makes the language a lot easier to use. And Python is super syntactic sugar rich. It's one of the things I personally love about it. And so that's going to do it for decorators. Hopefully you learned something. Hopefully you got some more insights into how Python works and how functions work. And remember, functions are just objects. So from all this here code happening, I want to say thank you so much for watching. I've been Mike, and happy coding.
Makes sense. Makes sense. All right. Bring this down. Bring this back in. Where am I? Okay. Get out of here. What just happened? Why did it shut off the... What's up with my internet? Still good over here. Damn. Just stopped working. Alright, don't let it stop me. Oh, another video, great. Let me bring this back in then. Cool. A little bit higher. Right there. That's cool. And yeah. Is this even gonna run? Yeah, my computer just started getting all weird, huh? I don't want to restart my device. Don't make me restart my device. I'm still streaming. Hasn't even been an hour yet. Come on. Don't break up the streak. Don't break up the stream. What's happening? I'm not going to get good service if I connect to my hotspot. Dang. Alright, I don't know what's happening, but I guess I'll try restarting the device. So I guess